close of Slack. Okay, notifications. That's right. Can you guys see my screen? All right. So I don't have any slides for this presentation. I'll just open up what this um, so so I think except Praveen and handful of other guys, everyone's pretty much new to the session. I think I've seen Rajesh before. So welcome guys, welcome to Go Study study group. So this is the fourth session. Today I'll be presenting on Soup, on the Soup Golang library. So Soup is a simple parser web scraper. It's similar to Beautiful Soup in Python. So Beautiful Soup allows you to scrape or rather go like extract information out from a document, like a HTML document. Like for example, if you look at the example in GitHub itself, it's actually by Anas Khan. So this is the link to the Beautiful Soup library. So what I'll be doing as part of this today's session is, okay, so I can give you a demo of the library if you want, but the idea of this session today is to go through to understand Beautiful Soup, to understand the Soup library written by Anas Khan, and to fix one bug as part of his as part of the Beautiful Soup library itself. So we have an open issue. There's a problem with the text function. This is not the error actually. I've created a test function for it. Let me first close up some of my tabs. My okay. So let me go through the test cases first. Please stop me whenever you feel like I'm going too fast or things are not clear. This will be a hands-on coding session. Like after about 10 minutes, we'll be working through the solution together. All right. So let me continue on this. So we have the test HTML documentation. So Soup has a pretty simple interface. Let me show you that first. Remove breakpoints. And so this is my main function. So this is a sample program which I'd written. Go concurrency constructs. I'll send you the link for this as well at the end of the session. So I have a HTML document, right, like Amazon's product page, and from that I'm getting results, and from for a product I'm able to access the text within a HTML content. Let me just open one of the show it on the console. I hope everyone's familiar with Chrome console. So here, what I did was using the XPath specifier, I have got this particular HTML in the page. Like for example, I can just inspect this. So this particular HTML I've got in the page, and I'm trying to extract the text from it. So with the browser, it's simple. I can just do text on it. The text on it. Sorry, it's not a function. So inner text gives me the text which I'm looking for. So similar thing. I can do it in Go using this using this soup library. I hope this is clear. So soup library has one shortcoming. So soup library has so like you can raise your hand in case I'm going too fast or something. Like it's not able to understand. Right. So it has one shortcoming. I'll first stash everything, all of my changes away. So I have this HTML tag, right? So if you look at the test for text function, I hope you all of you are familiar with writing test cases for your code in Go. We have this to a JSP page, and if I add a text right after that, like somewhere after the tag is completed, then the problem is my text function would not display the right. Like it does not even display JSP page, to be honest. Let me open the structure in a separate tab, all HTML. So this is the structure of my tag. The li element has some text and has a nested a tag with some other text at the end, right? So I'm trying to extract the text out of this li. So if I look at the node implementation of Beautiful Soup, I'm not sure if there is a way to run it right now, right away. Let me, you want me to show the behavior in Python, or shall I skip this and go directly into implementing it? I think I'll show the implementation in Python. I think that would make things clear. I think this pretty much would have the same behavior. So if I try to extract the text out of it, That's correct. Yeah. So, let me look, bring up this. Okay, so that's because I'm using double quotes inside this. Just escape these double quotes. Voila. So, if you look, I'm not. Is this visible now? So you have the correct output, which is to a JSP page, right? Like Beautiful Soup parses this text properly, this HTML properly, and when I ask for the text, it gives me back everything except the tags, like to a space JSP page space right question, as is. The same behavior in the GitHub library is not present. It's not the same behavior in the Go library. When I run this test, it should be to a JSP page, right? It does not work. It just stops at the first tag. It stops at the end of the first tag, which is 2A. So, are you guys still there? Okay. All right. I'll move on. So what Soup does is it parses. Okay. So the Soup library relies heavily on let me just bring up the code back. Git stash path. So instead of using the text function, I'm introducing a new full text function, which would, based on the li, it would bring up the correct text, which is to a JSP page right, instead of to a right, which is the current behavior of the text function. So this is just to maintain backward compatibility in the library. The code for this is, so the HTML parse function is what gets called by the soup library, by the test function. So so in the Python version, we have the equivalent, which is Beautiful Soup itself. So instead of that, in the Go version, you have HTML parse function, which calls the which takes in the string, which takes in the HTML string, which would get parsed. So the thing with Soup library is it relies completely on the Golang net HTML package. So this is a core HTML core package in Golang, one of the core packages in Golang. All it does is it calls the HTML parse function, and based on the return type, based on the error, it either checks for the type. It first checks for the type, and based on that, it creates a root wrapper. So root is something which is defined within the Beautiful Soup library itself. So this is where root is defined. Root has a pointer, which is the HTML node, which is the which is coming from net HTML package. A node value to indicate what the node type is, and the error. Don't worry about it. I'll just add a breakpoint to my code, to the code which I've modified. This is the full text function. Let me remove all of this code. Don't worry, we'll end up writing this for us. And let me add a breakpoint. So I have the soup library running. So this is a test function on the right hand side and the actual function. So if we look at the text function, it becomes quite mangled. It has a goto and all that. We'll clean this up by the end of the session. But before that, let me just run this, debug this code. Okay, the debugger is starting up. Let me remove all of the watches out first. So we have the root element, right? So the root element has a pointer, which is a net HTML node. This if you look at the code, so it has, so we are calling li.fulltext on the li itself, like the actual li, the parse li element. The parent for the li is not available. It's a UL, but it's not exactly. It is completely traversable, but we won't be worrying about it. So we are first looking at the first child, the last child, and also its previous sibling. Actually, we don't need the siblings. We need the children of this. This is where we'll have to figure this out. Oh yeah, okay. So what we could do over here, so this is our first child, which is our 2a. The next element for this would be first child dot next sibling, which is our a. So let me write the algorithm for this real quickly to get the full text. Dot pointer dot first child. So this is our let's just say this is our node. This is our first node, first child node. So for each of the siblings of the node, so we'll be traversing. So I'm not sure if you guys are able to picturize the structure of this package. So we have okay, let me go into the HTML HTTP package itself. Net HTML package, sorry. So this is the structure of node. So this is the structure of node. Stop debugging for a while. So there are certain kinds of nodes. We won't worry about that for now. For now, we'll just concentrate on getting this first cut done. So each node has a parent, a first child, a last child, a previous sibling, and the next sibling, which are all a reference of the node type itself. Apart from that, it has type, data atom, data namespace, and attribute. So data is where we have the text of the text from the document stored in this node. So what we can do is we'll have to iterate over each of the next sibling, and until the next sibling is reached, we'll be printing out each of the elements. So we won't be using this function as is. So if it's a text node, okay, I'll come to this code in a while. Give me a second. Let me keep that in. Okay, for some reason it ran the other test. Ran this one. Full text gave me wrong text 2A. Because we add the so this is an anonymous function which I'm using over here. I've actually copied this code out from another library. I'll show you that code and the library. Let me remove all these watchers. I just need n, and I need the value of data. This sibling, sorry, next sibling, and next sibling dot data. I hope this is making sense, at least beginning to make sense. So the program stopped. Okay, like let me remove this piece of code. So when it's a HTML text node, only then we are writing into write string, right? Let's look at the code again. Let's run the code again. probably not name this thing anymore. Strike key, pointer, first child, and that's it. We should be calling it on the next sibling. On the Mac. Are you guys able to follow what I'm trying to do?
Yep.
Okay. Am I going too slow? I would like to speed it up, but it's just that I'm not sure how many people are actually following it. So right now we have only element text node which we are looking at, right? We would want to look at not just text nodes, also usually our Go study sessions are not like this. This is the first time we are trying hands-on coding. Um, I'm not sure if this people are finding it useful right now. Like, how many people are new to Go programming in this session? If you could tell me in the chat also if you're shy talking. Okay, it's taking a while to run. My system has become slow. I think that's because it ran out of battery. I think Max kernel is running right now. Kernel code. It is horrible. My Mac has actually stopped responding. I'm sorry. Hello.
Gaurav, maybe you could close some other applications and try again. Wait a while, no problem.
Sorry.
I don't mind.
Actually, what I'll do is I'll wait until this. I'll just what I'll do is I'll restart my computer, but till that time, can someone else take over? Like you could talk about Go programming itself, like initiative. Okay. It's working now. I think the debugger has started. Uh, um, have to stop recording at this point. So it has come up. The first node is the text node 2A in my HTML. If you look at the right hand side, li 2A is what I'm getting right now. So next time we getting I stepped into. I'm sorry, I stopped the debugger. Bad.
Hey Gaurav, is it the debugger that is taking time? I mean, it's having CPU or something?
It's actually my laptop. Because the battery went low, I think max kernel task has started. That's pretty much eating up my RAM. Closed all the heavy duty shut OBS. I'll just try and close this application. Yeah, I'm not able to. I might not be able to continue on this right now.
Hey Gaurav, maybe we can wait a minute or two. You could reboot your machine if you would like. We can resume.
No, my machine is not responding at all. I've seen it happen. I haven't seen this happen like recently, but it had happened a month back. It would take a while for it to recover.
Righty.
So okay. So apart from this, what I wanted to talk about. So one was this code to fix the soup code itself. Apart from that, what I wanted to talk about was the other scraping libraries in Go. One thing which I wanted to emphasize on is open source contributions are usually not this hard. Like it's not hard to get started and to understand an open source library inside out. Right now, I've been struggling because the my Mac has is stuck. Um, there's there's another library for Go scraping. There are actually two other libraries. One is Coolly. I hope my browser at least works. Okay, awesome. So one is Coolly. Let me just open up the project page. So I actually came across these today, not day before yesterday. I can't actually. My terminal itself is not dropping down. It's like a okay. So it's the kernel task. I can't fill kernel task. That's the that's the thing which is eating up battery. That's actually a Mac issue. I'm using a 2014 Mac. Um, yeah, I think I should update the OS at least. Yeah, sorry man. Sorry Dinesh. Sorry everyone actually. Okay, so Coolly is a lightning fast and elegant scraping framework. So yeah, I'll let you read it. But one thing which I really liked about was the uh, distributed scraping aspects of it. So with Coolly, you can just start a new collector and then give it like define functions on it on the new collector, and you can start by saying that hey, this is the website I want you to start scraping over. So the API is much different than what you have seen with Beautiful Soup or Soup Library. It does not like linearly let you do this after this after this. Rather, with Coolly, you define callback functions that hey, on this HTML on this XPath, I want you to run this function. I hope this makes sense. So this is Coolly library. It does a lot of other cool features as well. Like it manages request delays, maximum concurrency per domain. So it handles cookie and session handling, which to be honest, doing it with Soup is it's not trivial. It's not a trivial thing to do with Soup. Sync, async, parallel scraping, distributed scraping, automated encoding of non-Unicode responses. All that is available with Collie, Coolly or Collie. I'm not sure what I should call it. Then there's one other simple library called Go Query. So it's similar to jQuery. Uh, I think most of us should be familiar with jQuery. If you're a new programmer, you might have heard of jQuery in the olden days. So what you see in Chrome browser, it's not jQuery exactly, but it follows pretty much jQuery-like syntax. So you can with jQuery you have the dollar symbol. Okay, this might not be visible. Is this visible now?
Yep.
Yeah. So you have the dollar symbol and you have access to the XPath. So you have something similar over here. So you don't have the dollar symbol, but you do have um, So you have doc.find. So this has so instead of so with soup, you'd have to provide class information. Like I can show you how I'm getting the find function takes a and then the attribute name which you want and the selector. So if you're dealing with deeply nested structures, you would not find this trivial with soup. You'd have to have a find, and after this find, you'll have another find, and then the other class, like a nested class information, to get to that information. Whereas with Go query, so sidebar reviews. So within a div called within a class with sidebar reviews, I can access a article element, and inside that, I'm looking for a with class which is content block. So I'm doing 3 levels of nesting inside, and then for each of them, I can provide a callback function. Like I can manipulate them directly. So Go query is powerful in that way. Like most of the code which I've written for the Go concurrency constructs, it would become much simple if I had to rewrite it with Go query. Let me share that link. So this is the link for the so you can go through the main function. It's just a simple use of soup. It's a demo application. It's just a demo code base. I hope my laptop is responding now. I think it is. So right, to the type is an element node, so it should write, and this one is a text node, so it should write this as well. To a write. Okay, so we have made progress. So at least it's right now going. So it has printed this, and then it has jumped to this right. Okay. So it's printing a twice for some reason. That I'm not sure why. And the other, oh yeah. So yeah, I got this actually. So it's printing a because the data contains the name of the tag. So there are 3 kinds of tags which we are parsing. So one is the text node. The second one is not a text node. It is a element node. And that's the next sibling. So that information is kind of lost. This. So it is it is an element node. So with the element node, I'll have to, oh yeah. So I can't parse a element node directly. I shouldn't be doing this. So with the element node, if n.type is an element node, I would have to get its first child and parse it in. Hopefully this should work. Let me stop the debugger again and start it again. Let me add a watch over here. N dot first child. The first child should have, the first child is a text node. So only the text node is what I need. What should be, it's a 2A. Interesting. So it's actually going inside the buffer.
Hey, Gaurav,
Yeah.
we're parsing the same text once, right? So it is going to go into, so end dot type is going to satisfy only one of the values in this one function call, right? You're calling f of n once, isn't it?
Uh, no. Okay. So it's not a switch case. So first, okay, the first n type, this would satisfy. So it would parse for the text node, right? So 2a is a text node. It would parse this and it would go inside the buff writer. Let me add one more breakpoint over here and one more breakpoint over here. Let's go to the next breakpoint. So the next breakpoint, it will obviously not satisfy because the text type is text node. So the node type is text node. So it will skip that. It will go to the next sibling. It would look at the next sibling, and since it has a next sibling, it would call the function with the next sibling itself. So which is a element node. It will come again. It will look at the element node. Now it's looking at the a tag. So it's looking at the a tag, which is an element node, and then it skips the first selector because it's a text node. It's not a text node. It goes into the element node, and element node in turn calls this function again with the first child, passing the node's first child as the argument. So the node's first child is going to be a text node, a JSP text node. Let's look at, yeah. Let me just run this. So it will come back again with the JSP page. It will immediately pop. It will immediately pop into the new tag. So the next sibling, there's no next sibling for this. It should pick up this JSP page and write it into the buffer because it's a text node. This next, it should not satisfy this condition, and it should not satisfy this condition as well because there is no next sibling. So it now comes back. The stack pops back into the execution of when we were working with the a tag. Now it looks whether if it has a next sibling, and yes, it sees it has a next sibling. It goes for the next sibling. It passes the next sibling into the function with the which has the data right and which is of type text node. So it will write it into the buffer. It does not have any next sibling, so it will skip this. Sorry, it's not an element node, so it will skip this, and it does not have a next sibling, so it will skip this. So this would end the function. There's no other further calls, and you should see. I'm not sure why it's showing that. I mean, logically, it seems like it should be correct. Let me run it from the command line. Go test 176. So it's complaining about this. Um, so all our tests pass actually. So let me just comment out and test this line. So without this line, our tests actually fail. And with commenting out this line, the test should still fail to a right, basically. So yeah, we wrote a new function called full text inside our text traversal function. Um our first open source contribution as a group, and this is pretty much what I had in mind for the presentation for today's session. This is pretty much the code which we have written. So we have fixed the so we have added a new function inside the soup code. We have written a full text function which which can which can parse even text which contains even elements which contains nested attributes, which contains nested elements. So that's pretty much it. Thank you.
Hey Gaurav, very nice presentation, man. Thanks a lot.
Yeah, thank you, man.
Hey Gaurav, I need
Professional.
to pop off to another meeting now, so I'll just drop off quickly. Nice talk.
Sure,
Yeah, catch you guys soon.
sure. Thanks, Praveen. Have a good night. Bye bye.